afternoon. Today is Wednesday, May 10th, 2023, and I am here with Frank Goodwin, who has served as the Director of Technology and Market Development at the International Zinc organization until his retirement in 2020. He continues to remain active in the steel industry, serving as a consultant to several organizations and metal producers. My name is Dan Baker. I am currently co-lab lead for the Global Body Structure Materials Lab at General Motors. This interview is being conducted as part of the American Institute for Mining, Metallurgical, and Petroleum Engineers Oral History Program. We are currently at AIS Tech 2023 in Detroit and are going to discuss Frank's experiences in metallurgy and his contributions to the steel industry and the overall materials industry. So welcome, Frank.
Thank you very much, Dan. It's a pleasure to be with you.
So essentially everyone knows Frank and I have known each other for a while. We've worked together on various projects in automotive steel research over the last decade or so, and it's been a great collaboration.
Yes, it has. Yes.
Let's start with your beginnings, Frank. Where were you born and where did you grow up?
I was born and raised in Bethlehem, Pennsylvania, and there's a little bit of metallurgical history that relates to that, which you might find interesting. The first zinc smelter in America was actually located in Bethlehem, and that got started in 1857. Until then, nobody really knew in America how to smelt zinc. But this fellow from Philadelphia, Mr. Wharton, came up and he was aware of the Belgians smelting zinc, and so he turned that zinc deposit into a zinc smelter. And there was a railroad fellow, the Lehigh Valley Railroad, Asa Packer, who was running coal from the Pennsylvania coal fields down to New York and Philadelphia. And he said, well, why don't you put your zinc smelter next to my railroad instead of next to your mine? And so that's what happened there. And then 2 years later, this is just before the Civil War, about 1859 or so, a couple of local land speculators said, well, there's iron deposits here too. So let's see if we can get a iron making operation going in Bethlehem. And they went first to the Secretary of War at that time, who was a guy named Jefferson Davis of the United States. And a couple of years later, he ended up running a different country during the Civil War, of course. But the government turned down these local investors. And so it wasn't until a few years later that Mr. Wharton, who had been running the zinc smelter, got interested in this. And he heard of a genius metallurgical engineer, John Fritz, who was out of Johnstown in the very early days out there as well. And but he is really one of the geniuses of steel metallurgy of the 1800s and up to about the time of the Civil War. So he got him involved, and that steel mill, what became a steel mill, got going in by the end of the Civil War. And so that area then underwent tremendous growth. What was formerly a rather unpopulated area really started to grow. And where my family gets involved is after the Civil War, we had a pandemic. The influenza pandemic was in 1918, and my grandfather and my grandmother were living in Philadelphia, which was the epicenter of that pandemic in 1918, and they wanted to get out. So my uncle had been born in Philadelphia. They moved to Bethlehem, which was not seeing the pandemic in 1919, and moved there. And then my father was born there in Bethlehem a couple of years later, and I was born in the same hospital as my father was sometime later. So that's really how we came about, and a little bit of a history about the local industry there. So the steel company, of course, grew tremendously and actually grew around the zinc smelter, and that went out of business around the time of World War I as the steel industry expanded.
Interesting. Tell me more about what your parents did when you were growing up.
Well, they really had nothing to do with anything that we're doing, metallurgy or engineering. My father was an insurance agent, and my mother was a teacher. She had some background in dentistry also, but it was really nothing to do with. I didn't draw any inspiration from metallurgy or engineering in general from them. That those are all influences from elsewhere.
Who or what got you interested in becoming an engineer?
Well, when I was young, I had an insatiable curiosity about everything I didn't know, and one of those was just taking all kinds of things apart in the house, and much to my parents' dismay sometimes. And so, as a result of that, I became pretty good about putting them back together and fixing them, and how to just fix things that I'd destroyed, and to stay in good graces with my parents. So I was rather mechanically inclined, and but also I I was not a friend of school, and school was not a friend of me. My parents really wondered about whether I was going to be seeing any academic achievement in my life when I was young. And so rather than being slotted into a college prep course, I was tracked into our local vocational-technical school in Bethlehem. And Bethlehem Steel at that time had sponsored a metallurgy technology course. And the whole idea there was to learn about stuff you would do in a metallurgical lab, and come out of high school with some sort of training that would take you into a union job working in the steel mill, and backing up all their work in production. And so I picked that up, and I just fell in love with it. It was the most wonderful thing I'd ever come across at 14 years old. And I had a wonderful teacher. This teacher just turned on all the lights in metallurgy for me. And the school had gotten a whole bunch of, I'll call it surplus equipment, probably junk, but old tensile testers. We had an old Charpy impact tester. We had a couple old muffle furnaces. We had an ancient metallograph with a big bellows, probably about 10 feet long, and we had grinding and polishing wheels and all the rest of it, and these old microscopes. And so he really taught us how to use all this and what it meant. And we'd heat samples up and quench them. We would then have to grind and polish, and we didn't have any cameras, so you'd have to look in the microscope and draw a circle and see what you saw, and then he taught us what it all was and how it related to the processing that was done. It was the most marvelous thing I'd ever run across, and so I did that in that school, and the miracles of all, my grades went up. So I just get interested in school. So it was the most marvelous thing to do that. And so that my teacher said, have you ever really thought about going to college? Because you really have something here, and you ought to think about going to college. And so we started talking about that, and he was a tremendous guidance for me to go on. And so I then had to climb a pretty steep hill to do all the things you need to do in high school to go to college. But I managed to do all that, and it was just a wonderful thing to find this wonderful passion and this whole subject of metallurgy at a very young age, and to have that. So it was just great that worked out the way it did.
Yeah, no, that's really great to have that sort of background all the way back in high school. Certainly think we could do more of that again and interest new talent into the industry. So after high school, where did you go to college, and why did you choose that?
Yeah, so with this wonderful guidance I had, and uh, with some very good recommendations, I managed to get into Cornell. And of course, I only looked at schools that had material science and engineering departments. It was the only interest I had in college. So I applied to Cornell, and got in. And I thought that was a kind of a miracle, but got in. And then after that, I went on to MIT, which also had a very good material science and engineering department, eventually ending up with my doctorate in material science and engineering from MIT.
Excellent. So obviously your high school experience really helped you pick material science and engineering as a career path. Was there anybody in particular that helped you along the way?
Yeah, well, my high school teacher, his name was Mr. Garahan, was this tremendous influence on my life. Also, in Boy Scouts, we had an Explorer post, and I was the head of that. A fellow named John Sinclair he was a Bethlehem Steel metallurgical engineer, and so he really helped me as well, recognizing my interest in all that. So, so these were two big influences during the very early days, and but it was quite tough to come out of high school with really minimal preparation and climb this very steep curve up into an Ivy League education. That was quite a lot of work too. And I was rowing crew. I rowed crew at Cornell, which took time as well. So that was it took me a while to really feel comfortable at the same level and then of course then to advance on to graduate school.
Right. Was there anybody in your college career that really helped push you along?
Yeah. So at Cornell, the professor who I really latched onto was Professor Che-Yu Lee, and his expertise was electronic packaging, but his industrial and other experience before entering academia was at U.S. Steel Research Lab in Monroeville, Pennsylvania, and also at Argonne National Lab. And so there was a nice meshing of personalities. I liked being with him, and he was a great professor at Cornell who really helped me along the way. And of course, then moving into graduate school, my thesis advisor, Mert Flemings, who has also been interviewed for this oral history series. I recommend you have a look at his as well. It's a marvelous recording that he did. And so, of course, working with my thesis advisor was much more intensive. And so Mert had a quite large research group, which I was very happy to be with. And that group was really focused on rheocasting and thickness casting, which are semi-solid metal casting. And I think I've included a picture of the continuous rheocaster from the MIT lab in the photos that we have here. So what Mert did was assign a postdoc, Ken Young, and he was a student of Dave Kirkwood's over at Sheffield before coming to MIT. And he was really my primary resource for my master's degree. And then my doctoral committee, Nick Grant, who's a legendary guy, and Joel Clark at MIT also, they were on my committee, and it was great to interact with them as my thesis work developed. Mert and I eventually patented my doctoral thesis, which was on semi-solid processing for ultra-high-strength aluminum aircraft alloys. So it was wonderful to see all that come not just to be a thesis in a library shelf, but turn into a U.S. patent.
Great. Did you have any classmates that helped influence you, either at Cornell or MIT?
Yeah, it's very interesting. At Cornell, I ended up taking more courses in physics than in material science and engineering. It's very funny how that happens. The science of the solid state physics, of course, is a big part of material science, and I became interested in that. The more sciencey part of material science, I guess, was very interesting to me. So the kind of people I found in physics, and this is, I think, what took me more in a research direction rather than an engineering practice direction, was to hang out with those sort of people. And it was so that was more of my group there, and I was in a fraternity at Cornell, which was much more of a social thing, not too much to do with my actual career with them. But it was wonderful to have this broadening of what I will call engineering science and moving more into the scientific part of physics. There was a wonderful background to get from there.
Great. What about work experiences during college? Did you have many internships or work study program?
Yeah, so I mentioned Professor Che-Yu Lee and that he had worked at Argonne before entering academia. So he was able to get me an internship at Argonne in the western suburbs of Chicago. And there I worked with Dr. Roger Popel, who was in charge of their radiation damage program. And so I worked on the Clinch River, Tennessee breeder reactor program, what was called EBR-2, which is the experimental breeder reactor. And so this had to do with nuclear power irradiation histories, because that's a very fast reactor for breeder reactors. A lot of radiation damage concerns there. So that was a very interesting internship. And that was back in 1973 or 4, and that's when I sent my first email, because the National Labs had the very beginning of an email system with teletype. So that was so long ago to have your first email. I remember that.
Amazing. Were there any big political or cultural events that affected your studies or changed your course any?
Not really. I was really focused on metallurgy, but I will say that when I was at MIT doing my doctoral work, they required a minor program, and I decided, well, let's do something really different. So I went to Harvard, and I said, I'd like to do a coherent set of courses in comparative literature. And I said, what? And I said, yeah. So let's just do something completely different. So I got my department to sign off it, and I got to go to Harvard for 3 semesters in the comparative literature department. And of course, the kind of students you have at Harvard were much more politically attuned. They're the sorts of people that end up in government and politics. And so that was living and breathing that stuff for them. So as part of our coursework, of course, these current events of the day would come in. It was very interesting that it just shows you how many different kinds of people there are in the world, because that was a very interesting group to interact over 3 courses there. So that was about the only relevancy, I guess, of current events through my formal education.
Yeah, it's quite a shift, I think, from the engineering and physics that you'd been doing up to that point. So after you finished your doctorate, how did you get your first job in industry?
Well, I'd come straight through. I had not taken any breaks from studying. I just went straight through from a bachelor's, master's, and then doctorate straight through. And I was ready for a break. I'd had enough of school for a while, and I said, let's go see what it's really like to practice all these things I learned. So to get my feet wet, I joined Chambersburg Engineering Company, which is in Chambersburg, Pennsylvania. And they did 2 things. They made some of the largest gray iron castings anywhere in the world, which, coming from the casting and solidification group at MIT, was very interesting. And they made forging hammers and other forging equipment, which went hand in hand, because some of the forging hammers used 70-ton anvils. These are huge. 70 tons is a very big chunk of metal. And so to run a foundry like that and be involved with that, and the sand that you need to use in the foundry for such large castings is a very strong kind of sand called cement bonded sand. So it was a very interesting company to work for and get involved with trying to bring some more science into the art of, there's a lot of still some art in foundry by putting thermocouples in the castings, especially when they are weighing that much and take a couple weeks to cool. So these Anvil bases were for their own equipment, and then the jobbing work was things like bell housings for coal crushers, these very big rotary coal crushers. So the end bell housings for those that rotate on these huge bearings, and also some of the largest gas handling or even fluid handling, like turbine casings for hydroelectric dams and blast furnace blower housings, these very large shells you could cast as one piece in gray iron. And so that's the sort of work that was involved. So we only did one pour every week or one pour every 10 days or so, but then we poured a whole lot at once to make these very large castings.
So, what was your position there, and what were your job duties like?
I was brought in as industrial engineer and metallurgist, and it was a real manufacturing engineering job. You had to deal with specifications. If a customer failure happened, it would come in for failure analysis and what happened. So I like doing that, using the metallurgical knowledge to come up with really what happened there and how do you fix it. Defining work practices, and so I was with, of course, the rest of the manufacturing team. They were much more production, and I was really the engineer dealing with new equipment that we wanted to bring in, machine tools and things like that. We had an old-fashioned iron cupola, which is a bottom-blown. It's kind of like a blast furnace. You have coke, and you've got scrap. We used to have railroad rail and engine block we used to melt, and that would be the way you make gray iron. And but to pour a 70-ton casting, you'd have to gather ladles. You had 20 or 15, 20, maybe 25-ton ladles, and try to fill them all up in sequence and keep them all warm and all ready to pour all at the same time to pour these huge castings. So there was quite an orchestration effort involved with that. So that was quite a challenge to do that.
Yeah, that does seem like quite a challenge. How was your transition to your professional life from research and school?
Yeah, well, as you noticed, it was all about research. Coming from doing a doctoral thesis and getting a patent on it, that was a wonderful thing. And so I missed research. It was great to get industrial experience and to just be part of running a company involved in metallurgical processing. But I did miss doing research.
What was your first major project?
So at Chambersburg, there was a lot of gray hair at the top, which I guess is why they hired me. They wanted somebody young to come in, and a new PhD with new ideas. And so the first thing I did, nobody had ever written too much down. It was very much, like I said before, more art than science. So I tried to come up with a practice and operating manual for the cement bonded sand work and how it all, the mixes and core and flasks and all that kind of thing. And so I wrote a little book about that and gathered that all together. And then I went through the rest of the place, and this company had its own forge shop as well. So how those pieces were made, and whether it was open die or flat die forging or impression die forging, and the various types of steel grades that were used from that, from the lower to higher carbons and so forth. And we also did a lot of forge welding of these massive pieces to forge weld, which is quite an art. And to try to document how you do that and do that consistently was kind of fun too. So that was really the first big project I did there, was just try to document everything using whatever knowledge perspective I could bring to that from my background.
Yeah, forge welding is quite the process.
Yeah.
Who were your mentors there at Chambersburg?
So the president of the company, Gene Clark, was a graduate of Cornell also, and so he was. That was one reason why I went there. But so he was running the whole company, and so as getting to know how a company ran. You come out of school and just how the organization works and how teams work and how all the commercial and industrial side of the companies, how a company actually works. I had no idea really. I don't take, at least in engineering, you don't take too many courses and that sort of thing. So it was really, so he was a wonderful mentor and then really gave me a perspective about how an industrial company ran.
Great. How long were you there?
So that was about a year and a half at Chambersburg, and then after that, I was starting to say, well, what's to do from here? And I thought there were some more challenges after that, so I ended up after that at Chromalloy Research and Technology Division in Orangeburg, New York, which is near the Tappan Zee Bridge up the Hudson River from New York City. And at that point in the late 1970s, hot isostatic pressing, or hipping, was becoming industrialized, where you heat a metal above its yield stress at the temperature of the heating, and then you can squash it, and you can make a casting sound just by deforming it above its yield stress. So, so that company had applied that to flight engines for jet engines and also for stationary gas turbines. And so I was working on product and process development related to that. They would take like a nickel-based superalloy, which is the moving blades, which are carbide strengthened, and solution treat those to make them soft again, do the weld repair, and then give them a very heavy nickel vapor coat, hot isostatic press them, and then you could close up any porosity that was left after welding and make a very sound turbine blade again out of that. So I worked there on the stationary, like these peaker turbines you see for cities during a hot day. You have basically jet engines that you can switch on and make electricity for peaking power to supply electricity. They're also used for industrial uses for pumping and so forth. So what happened then was about the fall of 1981, President Reagan fired all the airline controllers. That was the big airline controller strike. And so the flight engine business, they get rebuilt on a pretty regular schedule. And being a very new hire, after a year, I said, well, this doesn't look particularly bright for me right now. So I started looking around Thanksgiving, Christmas, right when this airline controller strike was at its peak. I said, well, maybe there's something else out there. So, but it was very interesting to work both in cobalt-based and nickel-based superalloys for that company. It was a nice added bit of metallurgy that was really good. So anyway, let's continue that story. So then one of the things that really changed my life was I was sitting around in this rather unbusy or shop that had not had a lot of work during this airline controller strike, and I picked up the Journal of Metals, which is, of course, the TMS publication, and this had an article in it. It was, I think, in the fall of that year, one of the late 1981 issues, and there was an article called "Casting with Zinc Alloys" by Duran Apelian, who also we know quite well, and Don Hershoft of the International Lead Zinc Research Organization. So these two had put together an article, and JOM had published it. So I said, well, that's interesting. This is really kind of, and it is, Duran was doing research, and I knew Duran through my MIT connection as well, even way back then. So that was, I felt very comfortable about that. So I called up Ilsro in New York City, and I said, hey, I'm looking for a job. And I said, well, we're a very small company. We're a small industry association, and no jobs are open. But I said, send your resume in anyway. So 2 weeks later, the president of the company, Schrade, Radtke, called up, and he said, get in here 41st to Madison, and then we'll interview you and see what's going on. And so it turned out he also had his degree from the metallurgy department at MIT, and so it became more a question of who do you know and who do I know, and he made a few calls up to Mert Flemings at MIT and others, my recommendations. And so that worked out wonderfully. And I began my career in the zinc industry on February 1st, 1982, not too long after reading that Journal of Metals article. So that was a wonderful thing. And just coincidentally, walked in the first day of work, and my wife-to-be was working there at the company. So I met her my first day of work in 1982. Just continuing the story there, I advanced in the company at Ilsro and moved through various positions up to executive vice president in 2004. And during that year, Ilsro and the International Zinc Association and the International Lead Association all merged, and we consolidated our operations, and I became the Director of Technology and Development for IZA upon their founding in 2004, and was in that position until my retirement in 2020. So that IZA job encompassed all of our research and development activities globally. Outside of what was going on in life sciences, we had another department dealing with health and environment and so forth, but I did all the non-life sciences research. I was in charge of that together with all of the market development work. So, and as part of that consolidation, it was a big growth period for IZA. We had our office in North Carolina. We moved out of New York, in Brussels, and then we opened regional offices in Shanghai, New Delhi, Lima, Moscow, Johannesburg, and Kuala Lumpur. So as global director, I was trying to give all of those offices program support, hiring people, and working with them on all of the different uses of zinc and the research and development programs and the market development programs that each area would come up with.
So during this time, were you mainly focused on zinc-coated steels, or were you dealing with other products other than life sciences type applications like you mentioned?
Yeah. So I dealt with all the uses of zinc. So I dealt with coated steel from the very beginning, of course, and not only continuous galvanized sheet steel, but also the wire business, a galvanized wire, springs and all kinds of things like that, fence wire, other kinds of wire, die castings, pressure die castings, zinc anodes, and then we have zinc oxide, which is used as a vulcanization accelerant in tires, for example, in the auto industry and many other things, suntan lotion, and just all the uses of zinc that are out there. The U.S. penny was converted from copper to a copper-plated zinc in 1981, so I came along not long after that. So that was a lot of work in that as well to develop that further and look for coinage opportunities in countries other than the USA. So it was just always involving the R&D needed to move all these areas ahead and to take advantage of market development opportunities. And sometimes those needed more research, which I just love doing.
Great. So tell me a little bit more about some of that research and work focus, both at IZA and Ilsro prior.
Okay. So you know that the auto industry until about the late 80s, we didn't galvanize auto bodies. In the auto industry, we had zinc-rich paint, and we had other ways that we tried to deal with corrosion of auto bodies. And then finally, the situation with road salt and corrosion, body corrosion, just they said, you know, we have to do a metallic coating of zinc on steel. Otherwise, we cannot get our 10-year perforation, 5-year cosmetic warranties, which everybody wanted on the automobiles. So there was a huge change to go, and a huge opportunity then for an engineer or a metallurgist to get involved in how we're going to galvanize all this body and structure sheet for automobiles, and that was quite a huge effort, a step change in the quality requirements for the steel mills to move up to auto body and structure coating. And so some of the surface quality issues, but not only that, the mile per gallon, the fuel economy requirements became more and more demanding, so looking for lightweighting of steel. So a huge problem was how the heck are you going to galvanize all these steels and keep the mechanical property requirements for these steels after you go through all this processing? And so the combination of those two things led to a suite of projects that I put together and managed to get a number of our steel industry friends interested in co-funding with the zinc industry and some suppliers. And that led to a formalization of all these in 1999 that we call the Galvanized Autobody Partnership. So that is a program that is still running today that involves quite a number of programs to support the automotive use of zinc-coated steel. But that was only part of my job description. The die casting industry also needed a lot of help. They were still using alloys invented in the 1930s by New Jersey Zinc, and so that hadn't really changed. And the two biggest drawbacks of zinc die castings are, first of all, high temperature. Zinc's a low melting temperature alloy, so you take it up to for example, an engine compartment temperature, and it's going to creep. It's going to deform under load at any temperature near an engine temperature. And the second is it's a fairly dense metal. If you compare it with aluminum die castings or with magnesium die casting, it's pretty dense. So working with North American Die Casting Association, and they had a director there called Steve Edvardi in Chicago, and I was very happy to work with him. And over the course of time, we won 2 large Department of Energy grants to develop completely new alloys that answer both of these problems. One was a very high creep strength alloy, and we did a lot of funnel work. How does creep happen in these alloys, and how do you make zinc alloys more creep resistant? And I was very fortunate to run into Frank Nabarro, who came up with the Nabarro herring creep mechanism some years ago, and he was ready to retire by then at the University of Witwatersrand in South Africa, but he agreed to help me out, and the work there with CSIR, which is the national lab in South Africa in Pretoria, we came up with a wonderful composition with many times the creep resistance of conventional zinc die casting alloys. So that has been commercialized now as what's called the EZAC alloy, EZAC alloy. So that has entered new areas where zinc could not go before with much higher temperature capabilities. And the second one, we had another Department of Energy project for the density issue, and there we came up with ultra-thin alloys because a lot of times the shape capability was limited by castability rather than mechanical strength. And so coming up with very thin alloys was a real development there. So that's turned into an ASTM B989 is the specification there for that new ultra thin alloy. So we now have very lightweight castings, and we also have ones at very high temperatures. So I was very pleased to lead and fund and be all part of all that. Just to finish the story on the different areas of zinc, there's another very large part of the zinc application and consumption, which is for after fabrication galvanizing, or we call batch galvanizing or general galvanizing. So this is where a part is fully fabricated. For example, you'll see stairs or grates or guardrails or structures or heat exchangers. Many things are made from steel that then need corrosion protection, and they are just dipped wholesale into a big zinc bath. And so the problem is these steels have very different reactivities from one another, and this really we discovered, and it's been known for some time, that silicon and phosphorus are the two things. The silicon-killed steels to get higher strength are very important determinator of the reactivity. And this had been looked at in the past. However, it had never really been reduced to much of a scientifically organized body of knowledge. So over a course of years, I worked with University of Cardiff and University of Swansea in the UK and Wales, and we put together a whole story there by looking at hundreds of compositions and digging into all the metallography and the thermodynamics of how that all worked. So the general galvanizing industry was very grateful to have this new knowledge, and it really has allowed the general galvanizers to have some guidance, and so they come out with more predictable results for the steels that they are galvanizing. So that was a nice thing to put up there. So I think that really covers the main uses of zinc that I've been involved with intensive effort, which are the continuous galvanizing, the die casting, and the general galvanizing.
So can you talk about some of your technical contributions to industry?
I mentioned before about the automotive steel challenge, and the development of, or contributing to the technological platform and the knowledge platform that we have about galvanizing advanced high-strength steels for automobiles is certainly part of that. And some of the things involved there are galvanneal reactivity and the role of titanium and niobium in galvanneal reactivity. A lot of the fundamental work on internal and external oxidation, and we knew about internal and external oxidation in steels for many years, but its applicability to galvanized steel processing and how it helps us to come up with really nice coatings on steel is another area where I was instrumental in developing a tremendous amount of work on that. The galvanizing bath itself was not very well understood. The equilibrium in the bath, the formation of intermetallics and drosses and oxides, and the control of aluminum and iron and perhaps other elements in the bath, and the whole scientific description of the temperature and flow and composition fields in the galvanizing bath, which is made possible by the wonderful computer flow software we have these days, was another one. And then finally, I would say the coating control developments for continuous galvanizing. A lot of our knowledge, if you go back to some of the earlier work, was based upon coating of non-automotive steels, and to work with the strip to knife distances and gas pressures that are required for automotive steels required really an extension of the past work to provide predictive modeling for the advancement of coating control and helping that to achieve a closed loop coating control in many cases. So all of these things that I've mentioned are essential for steel-based automobiles these days. And I mentioned before about the die casting alloys, the two families of die casting alloys that we came up with there, and some of the general galvanizing work as well.
How about a few comments about what you've done with AIST and the Galvanizing Technology Committee?
Yeah, so I think one of the greatest accomplishments is bringing people together. And I was very pleased when AIST was founded from the joining together of ISS and the AISE in, I think it was 2003 or 2004. They invited me to be the founding chairman of the Galvanizing Technology Committee. And that is and continues to be a wonderful platform for all of our educational developments. There's a lot to learn from our colleagues and to bring together everybody in this forum, and on a regular basis as we do, it's just all part of, and then the other things I do also with the Galvanized Alloy Partnership and other industry association programs. It's all about bringing people together and advancing everybody together, learning from each other. So that's been a wonderful thing to do. And I'll I'll talk a little later here about some of the conferences that really do the same things.
So can you tell us a little bit more about your involvement here at AIST and the galvanizing technology committees?
Yeah, that's so a big part of, I think, what I've achieved is through many forums to just bring people together. And it's so important to do this because we all learn from each other, from our experiences and from our knowledge that we all come together and share. Back when ISS, the Iron and Steel Society, and the AISE, the American Institute of Steel Engineers, merged to form AIST, and I think it was 2003 or 2004, they invited me to be the founding chairman of the Galvanizing Technology Committee. And we turned it into a very nice, open-handed group of people, of producers and suppliers, and we shared a lot of information together. And that has been now almost 20 years since that's happened, and you've been involved in that as well. So that's one aspect of working with AIST on these things, and putting together as papers co-chair since then the annual AIS Tech galvanizing technology sessions, and also the MS&T sessions that we have on galvanizing of advanced strength steels for many years has been a nice part of bringing together and learning from other people as well.
I know we'll probably talk about some of the other things as far as conferences go in here shortly, but do you recall any significant experiences working with colleagues that you want to share?
Yes, of course, and that's colleagues, of course, really enrich your life. So I mentioned before Schrade Radtke, who was the president of International Lead Zinc Research Organization, who hired me. And after I came on board, he really took me under his wing, and we went all over the place. The Galvanizers Association meeting in April of 1982 was in Monterrey, Mexico. So that was wonderful to and really meet everybody from the industry down there. Quite a number of our steel friends were there. And then he put me in charge of the Galfan development, which was the zinc 5% aluminum metal hot dip coating effort. And I worked with that and to try to develop that, and eventually we came up with 98 licensees in between the various steel coating industry sectors, such as steel and wire and tube and other things, and also the alloy suppliers. So there's a nice picture of from 1983 of Schrade and myself at the tender age of 29, and also Dr. Yosuke Hirose from Nissin Steel, and he's really the godfather of the zinc aluminum magnesium coatings. He was the first one to really suggest that these coatings had promised, and 10 years later, of course, they were commercialized by Nissin Steel. And also Jacques Pellerin is in that picture, who was working for CRM, and he did a lot to develop the jet vapor coatings, the JVD process that ArcelorMittal has now taken commercial, nearly aged there. So moving beyond Schrade, I also was very fortunate to strike up with Professor Bruno de Cooman, who received his doctorate from Cornell in material science and engineering, and went back to Belgium. He was on a Fulbright when he was in the USA. And so we did some of the first work on galvanizing of trip steels together. And that was in the early 1990s. And it was some marvelous ferrous metallurgy work that Bruno did with us there, really defining what we call the silicon phosphorus aluminum triangle that we use to define trip steel metallurgy. And after that, he continued at POSTECH, the Pohang Institute of Science and Technology. And when he was there, he managed to have me appointed as an assistant professor. So I came over to Pohang once in a while and did some special topic seminars for the students that were there. And that was kind of interesting because you get used to an American university, and then you go to Pohang and all the students bow when they talk to you. And I said, yeah, couldn't we do that at home too? That was kind of a different attitude over there. And one of our friends, Michel Dubois, I'd like to mention. Michel was quite a character. And first of all, to finish up with Bruno, after he moved to the Russian steel industry. He was killed, and I really miss him. I just think of how much Bruno would have contributed since then if he was still alive, and I really wish he was still with us. And then moving to Michel, I do have a picture of Bruno and Michel and myself here to show, and when we were together at the AP Galva conference that I helped to organize on Jeju Island off the south coast of Korea. He was a process engineer at Cockerill before that became part of ArcelorMittal. And then he joined the CMI, which became John Cockerill. And Michel and I both were very curious about how things worked and like to take things apart and understand. And Michel's office was full of just stuff. You'd walk into his office, and he had dart guns that he would shoot at the strip with a thermocouple bead that would unspool, trying to measure for the first time the cooling rate of the strip as it went up the tower until the wires fell off. So he would just do crazy stuff like that. He had little acoustic transducers to try to measure the vibration of the strip, and just a wonderful attitude about what's really going on here, and trying to figure it out, and asking questions that were obvious when you heard them, but you realize that he knew how to ask them really good questions. So Michel has really helped, I think, all of our understanding about what's really going on, and how to measure, because you have to measure things to understand them in the galvanizing process. And then I'd like to mention Professor Arnie Marder, who was at Lehigh University. And I funded him to do a lot of work to really the basic work on galvanneal. He taught us a lot about galvanneal. And in 1999, he said, we've done a lot here, and I want to write a review paper. And so he had a sabbatical at Technion in Haifa, so he went over there for a year. And at the end of the year, this marvelous review paper called The Physical Metallurgy of Zinc-Coated Steels came out. And I think that is or one of the most cited papers ever in our field. I think it's got 5,000 or 6,000 citations. And so during the pandemic in March or April of 2020, when we were all locked up, he got a hold of me and said, you know, that paper I wrote back in 2000, he said, it's been 20 years, and we need to update that. At first, I thought he was asking me for money. So I said, well, let's do it together. And so the more we talked about it, the more we realized just how much has happened in this field of zinc-coated steel in the last 20 years. And it turned into a book. And so we then signed a contract with Elsevier and just got to work there and cracked away at it for 2 years, and just finished up at the end of 2022 here, 2 years later, and was published and came out for sale in March of 2023, very recently. So that Magnum Opus now is out there, and then so to work with Arnie for 2 years on that, it's so if anybody ever wants to write a big book, 688 pages or so, I really recommend a co-author. You need to support each other technically and emotionally and everything else. It's a very daunting undertaking, but I think we're very pleased with how that book came out.
Yeah, I'm sure that's going to become the new most cited document out there in zinc.
Yeah, there's a lot in there, and there's a lot in there that was never all assembled as a body of knowledge before, so we're very pleased about that, yeah. So then thinking more about internal people, I mentioned before that IZA expanded globally, and I was very lucky to be put in charge of a lot of how that happened. And so, of course, in 2004, China was just developing by leaps and bounds. They said, oh, we have to have a China office. So I actually went to Wuhan, which was the steelmaking center of China historically, in 1984, which was the year the first coil-to-coil galvanizing line opened in China, which was a horizontal Mannesmann line. Until then, sheet galvanizing in China was a piece-by-piece operation. They'd take 1 or 2 meter long pieces of steel strip and dip them in the bath by hand. And this was how you made galvanized sheet in China until 1984, which is just amazing. And they were still doing some of that when I was there. But then they got this line. And so I'd been working with the German steel industry on the Galfan development, which really took off in Germany in the late 80s. And so the Germans who had, of course, with Mannesmann, they were looking for somebody to go over who really knew English quite well, too, and was a metallurgist. So I ended up, the Verein Deutsche Eisenhüttenleute, the German steel industry, took me over and said, go to China. In 1984, it was really a very different world to go there, and to go to Wuhan and work with those guys on that was very interesting. But at the same time, their zinc supplier, Zhuzhou Smelter, was in Changsha in Hunan province, and I got to know their foreign relations lady, a very young lady at the time, Annette Huang, and so we got to know each other over the years, and we put together the first global zinc producers conference to show the Chinese zinc industry what's going on, and we had all the Europeans and Australians, North Americans, everybody, South Americans were there. So it was a wonderful first attempt at having a global, again, bringing people together. Was so important there to bring together the whole industry. And then eventually Annette agreed to come work for Isostatic. So we established our Shanghai office. Since then, I mentioned Isostatic was formed in 2004. And so she and I just traveled all over China. I've been to so many places in China, really every corner of the place, talking with automotive manufacturers, steel suppliers, and we also got into die casting and some of these other things as well across the zinc industry and all the zinc smelters. So, so she opened up wonderful opportunities for me to really. I've spent about 1.5 years in China overall, if you count up all the days. It was an amazing experience to develop that office, and of course we hired other people too as we went along, and we also developed a Chinese group of steel companies that joined the Galvanized Autobody Partnership that I mentioned before. So that became a regular way of exchanging information with the major Chinese mills. Then beyond China, we established an office in Moscow, and that's a little more difficult on the organizational side, but on the people side, it was always fine. You know, you're dealing with people is quite different from dealing with the bureaucracies of countries and so forth, so that was always fine. So Vladislav Polkin was a metallurgist there who we picked up, and he and I did many seminars over the years in both Moscow and other places, and the location of the main zinc smelter, which is in Chelyabinsk, which is in Siberia. So going there in Western Siberia to give seminars in January was bring all your warm clothes. So I think I show a picture of that seminar that we did one winter there. And the Russian Orthodox has a holiday in January where it's kind of a baptismal thing. So you go in January in Siberia and you jump in the lake, and that was way below zero. But I think what I gathered of it, I did it with my friends, is the main purpose of that is to get a bottle of something to warm you up afterwards, and that was the main purpose of that. So that was a bit of time in Russia. Yeah, beyond China and Russia, we also, of course, dealt with our Indian market, which has been growing by leaps and bounds and still is. So we established an office in Delhi. Rahul Sharma, our manager of that office, I was very pleased to work with him for many years. And he was very instrumental in developing our relationships with the steel industries in India, especially Tata and the Jamshedpur complex and their main research laboratories there. The Steel Authority of India Limited, SAIL in Ranchi, and also Jindal or JSW, who has operations and including a huge expansion now going in Hampi in the middle of India. So just as in China, all of these the success of all these programs were all about developing relationships, not only with the local industry, but also with the governments, things like developing corrosion warranties and other aspects of market access and developing all these markets. So as part of that, we held many seminars and conferences in India. And I'm just showing here a picture of Steve Wilkinson, who was the executive director of ISADA, and myself. It's very traditional at an Indian conference to open it with a lighting of the lamp of knowledge, which is what we see here. So this was happening over all the conferences that we did. We would start out and usually get a government official to participate with us as part of our development of these markets. One conference that I've been particularly closely associated with is the Galvatech series of conferences. This was started in 1989 by Professor Hitsumatsu and Professor Yamaguchi in Tokyo, and so the Japanese really led the way on developing the Japanese character, really, of much of the Galvatech conferences. I participated on the organizing committee for Galvatech 95, which was run by ISS, and then I co-chaired the Galvatech 2004 with Debanshu Bhattacharya, DB, of ArcelorMittal, and so that was a wonderful experience to work with him, and that was the year after AIST was founded. So that was the beginning of a very close relationship with AIST. So then. After that happened in 2004, then the Europeans asked me, you did such a great job in Chicago with 2004. Could you come help us in Genoa in 2011? So Joseph Fotterl of Voestalpine and Thomas Cole of Salzgitter and I co-chaired the Genoa meeting of Galvatech 2011. And then the Chinese, of course, wanted to get in on the act. So the vice minister of the metallurgical industry, Ru Yulin, rather, he and I were the co-chairman of Galvatech 2013 in Beijing, and you were there. I remember.
Yep. That was
a big conference that you were part of there, and so we really exposed the entire Chinese steel industry to really advances in technology that we were able to bring out with the Galvatech conferences. So after that, Professor Joe McDermott of McMaster University, and I co-chaired and it was organized by AIST, the Galvatech 2015, which I think is still the largest attendance that we've ever had, because we did it together with the PHS, the Press Hardened Steel Conference. I think we had over 500 people for that one. So that was another good experience. And then the Europeans then, I guess, asked me again to co-chair the 2020 conference, 2021 conference, but then COVID hit and we couldn't do that. So that was a very interesting experience to co-chair that again with Joseph Fotterl of Voestalpine, and that was all virtual on Austrian time. So we were all up at 2 o'clock in the morning to give our speeches, sitting here in the dark all on European time. And we did come up with a Galvatech Highlight Symposium the following year in Vienna when the world started opening up again. And now we go to Galvatech 2023, which will be in Seoul. And the Koreans have asked me to co-chair that one as well. We have 190 papers coming to that one. That's all set up now. And I think that'll probably be my last one. It's time to pass the torch for the next one, because that'll be in Monterey, another AIST event. So our personnel from Joe McDermott at McMaster and Omar Garcia of Ternium will be co-chairing that one. I'll probably be coming along and just to be there to be with my friends.
Great. Yeah, we're looking forward to all the upcoming Galvatech conferences. Could you tell us about the awards and honors that you've received throughout your illustrious career so far?
Well, I've been very fortunate to receive a number of these. I mentioned before about general galvanizing, and so there are industry associations around the world. The major one in this part of the world is the American Galvanizers Association, and they gave me their Hall of Fame award in 2021. And also the European General Galvanizers Association gave me their Silver Pin Award in 2007. For the die casting industry, I received the Nicelius Award for Exceptional Technical Achievement. That was in 2018. And just recently, I received that industry's most prestigious award, which is the Herman Doller Award. That was in 2022. And then moving to the sheet galvanizing industry, the Galvanizers Association's most prestigious award is the Nevison Award, and I received that in 2009. When we had the meeting in 2022 in Berkeley, South Carolina, we assembled the four Nevison Award winners that we had on hand there, Professor McDermott, myself, Brian Lester, and Ed Silva. And so that was fun to all get together again. And I'd just like to give a special note about Dale Nevison, who really was the leader of all that. Dale was a native of Detroit here, and we worked together very, very closely over the years. And he's another one that I miss very much. I was also, I mentioned before about WIRE, and I was made a life member of the WIRE Association International for contributions related to wire galvanizing. And then way back in time, about 30 years ago, AIME gave me an appreciation award for all the support for the U.S. Lead and zinc mining industries.
Great. What sort of milestones in industry do you think you've had the biggest impact on?
For the sheet galvanizing industry, I think the gaining of control of coating weight stability has been a real milestone where we were able to provide a much narrower window of maximum and minimum coating weights, which for automotive is, of course, especially important for formability and weldability. And this has come about through the development of much more highly engineered gas wiping knives, which are now designed using scientific principles, together with the measurement and the feedback control equipment that we have here. Also, I mentioned before about galvanizing bath management. I think I've contributed greatly to the scientific understanding of how the interaction of the flow fields in the bath, the temperature fields, and the composition fields all interact and can be managed to provide very high quality zinc for dipping the steel into. As you know, every moment you're putting steel into a zinc bath, you're creating a reaction between steel and zinc, which has potential for making intermetallics and dross. And to understand how to do that so you have the least possible impact on the zinc quality is very important, and we've learned a lot about that. Also, the development of much more durable bath hardware equipment, both the bearings and the bushings that support it, together with the minimization of buildup on the roll surfaces. So I think there's been a lot of knowledge that I've been instrumental in helping to conceive the project and organizing the funding and getting the work done there. So beyond that, just working with all of our colleagues on just how we develop these high-strength steels so that they actually are galvanizable, and producing successful zinc coatings on so many of the new steels that we're seeing.
Can you tell me how your membership in the different societies has evolved and how you first came to hear about AIME and get involved with AIST? And its predecessors, I should say.
Yes, sure. Yeah, I mentioned before I had that little recognition award from AIME for lecturing at one of their lead and zinc conferences about 30 years ago. So that was AIME proper. With the AIST, it had its predecessor organizations, the ISS, the Iron and Steel Society, and the AISE. And so I was a member of ISS for some years before the merger, and certainly with the organizing committee of the Galvatech 1995 and before. So when AIST was founded, then we had the Galvatech 2004, and also I founded the Galvanizing Technology Committee at that time. So I've been very pleased to serve our Galvanizing Technology Committee, both as the chairman and as the paper's co-chair for many years, helping to organize all of the technical sessions at AIS Tech and also the advanced high-strength steel galvanizing sessions with MS&T over the years. So it's been a just been a very nice way of bringing people together and joining in the possibilities we have here to work together in these association committees.
Can you elaborate on how membership in professional societies has benefited you in your career, and how do you see our societies benefiting people going forward?
Well, I can speak personally that you think back to when you got your final degree from university and what you knew then versus what you know now. And most of what you know now, you did not learn in school. You learned it along the way. Yep. And what AIST, our committees, and our other collaborative activities, I mean, they have been a huge part of my continuing education. And a lot of that has come from, me talking with you and us talking with the suppliers in the industry, and we all learn from each other. So the forum or the venue and the chances to join together and to just continue learning from each other, and then to watch everything evolve, and a lot of it has a lot of science based underneath it. We really have to come up with a lot of science to do these things, and we have worked on these things together. We've sponsored research projects together at universities, and so our membership involvement has really allowed and really facilitated the collaborations that have resulted in our continuing education for all of us. So I just show a picture here of the 2017 AHS conference that we had in Keystone, and that was we had people there from the automotive industry, from the steel industry, and academia, and it was a big part of our continuing education together.
Who helped get you into the societies?
Well, I think a lot of it was self-motivated. I wanted to, because I work for a very small industry association, International Zinc Association, and really was trying to lead the group to advance their objectives. You realize that you have to be involved. You're not going to work just as an island in a small association. You have to get out and collaborate with people. So I drove that, and I've encouraged others in our association to be part of the whole collaboration here.
So what would you say to a senior in college or about to graduate master's or PhD student to get them interested in joining societies?
Well, the first thing that I always try to impress upon, our younger generation is you never stop learning, and you can never stop learning. I mean, to even stay still, you have to, because everybody else is moving forward. You have to keep learning, and what these various opportunities you have in these associations offer is an opportunity to keep learning, and to be part of the technical sessions, and to take part of these committee meetings where we're sharing our experiences and what worked and what didn't work, what's new, what new opportunities are there out there, what challenges are there out there. These are all part of our never-ending effort to just continue our education, which is just vital and necessary for our continued professional development.
And what can we do to attract new young people into steel and zinc-coated steels?
We need to continue programming meetings and meeting content that will meet their needs. I think we have to understand the place where young people are today coming into industry from. They're coming out of school, and certainly when I came out of school, I knew very little about the industrial experience. MIT was very much like a government research lab with students in it, and it was not much like industry at all. So to get out and actually be in industry is a very different experience. And to have plant tours and to present topics of current interest, of new things that are coming along from our industrial experience, I think would be very beneficial to young people.
Excellent, thanks. Yeah, all good comments. As we start to wrap up here, what has made working in this field meaningful to you? What has been your favorite part of working?
I think just finding out that there are a lot of people here who have common or mutual interests. That we all have common goals to try to, and common challenges that we're trying to meet. And as a program developer in a industry association, I've always tried to develop programs where people would feel that they have something to gain if they join in. If they help to fund a program, they're going to gain something from it. And I think looking at across the board, you always try to find things that are of our mutual interest and where we all have something to gain, whether it's programming an AIST conference or a galvanizing session or putting together a research project. You really look for the common platform. And I think the associations have helped greatly in providing a perspective on what that platform should be, what the opportunities are, and of course, allowing us to meet all the contacts, the different people who are like-minded in the field.
So what advice can you give to today's young leaders in engineering professions?
Yeah, well, leadership is distinct from just learning as part of the group. When you're a leader, you always have to be thinking about what's next, because if you're going to lead the group, you have to know what's next before they do. And you have to say, okay, now we're going to do this before they've even stopped thinking about what they're doing right now. So my advice to people and young leaders trying to develop their leadership potential as an engineering professional is to say, okay, we're here now, but what's next? And what do I need to assemble? What resources do I need? What people do I need? How do I need to prepare for what's next and to think about where this next step is beyond?
Excellent. Is there anything else that you'd like to bring up that we haven't already talked about?
Yeah, well, I mentioned way back that I met my wife-to-be on my first day of work on February 1st, 1982, which is about 41 years ago. And for some reason, undeserved to me, but we're still together. And I'd just like to acknowledge my wife, Rosalind, who's given me so much support over the years. We have a picture here when we're at the Kentucky Derby. So there's been a lot of travel involved, a huge amount of international travel, as we've mentioned. And this would have been impossible to do without her constant support.
Great. Yeah, you've had certainly quite the career in both steel and zinc coated steels, on top of all the other things that you've done. It's been my pleasure to spend this time talking with you about your career and getting this recorded for the future generations to look back on what we were able to accomplish over the last bit of time.
Thanks very much, Dan.
Thanks.